Hello everyone. In this video, let us discuss the important interview programs called linked list cycle from LeetCode platform. So it's program number 141 from Easy Level guys. First, let us see the problem statement. So afterwards, I'll explain with some sample input. Okay. Finally, let us see the program. So head address is given here. That is the head of the linked list. So determine if the linked list has a cycle in it. Okay. So there is a cycle in linked list if there is some node in the list. So can be reached again. So by continuously following the next pointer. Okay. Uh, with example, you are going to understand detail. Internally, position is used to denote the index of the node. Okay. And the tail's next pointer is connected. Okay. Connected to. So note that position is not passed as a parameter just for understanding. So here, they given the position. So we need to return true if there is a cycle in linked list. Otherwise, we need to return false. Okay. Observe this first example, everyone. So the last node next is connected to the node called two here. Might be so the last node next. Might be connects to the any node. So here, but in this example, you can observe that it's connected to the node number one containing the value to s. It is position value one is given to that position it's connected. Okay, cycle is existing here. We need to return true. So here, so to position zero, so last node next is connected. Okay, again, so for this one also we need to return. So here, position minus one is given. Okay, so there is no cycle here. We need to return the false. Okay. So observe the follow up, everyone. Can you solve it using order of one? So the extra memory, constant memory. Okay. So means without using any extra memory, we need to design it. Okay. So it's again from two pointers. Okay. That is actually this one we can design with the hash table. Okay. So there it actually takes the more memory. Okay. But with the help of two pointers, okay, you are going to observe using of some extra auxiliary memory locations. Okay. Order of one constant memory you are going to observe here. And so the similar questions to this one is linked list cycle two. Okay. Uh, so here we are going to identify whether cycle is existing or not. Okay. So in the linked list cycle 2, so we need to find the starting point of cycle. Okay. So in these programs, we are going to use a slow and fast pointers approach. Okay. So how that approach, two pointer approach helps us to design here. Once again, let us discuss in detail now. Okay. With the help of example. So all of you have a look at once. Let us take the first example, guys. Okay, one, two, and three. Next of all, so the four, right? So what happened? This four next is connected to the node two, right? Okay, it's not connected to the none. So that intuition, okay, that thought process. So here is okay. So actually, you observed the slow and fast pointer approach in the finding accessing exactly middle node in the linked list, right? Okay. So always fast pointer is ahead of slow pointer, right? Okay. So here, so if you carefully observe, so slow pointer on reaching to the last node. So again, so it may move to the any other node in the linked list. Okay, it can be to the node one, or else so it can be to the node two, or else it can be to the node zero. So might be I'm connecting the last node to the any one of these nodes. Okay, again fast pointer is going to reach. Okay, right in this position. So means once again what happens? A slow pointer is behind of fast pointer, right? Okay. So on updating, so the slow pointer and fast pointer, so the continuously. So chances were there to meet both these two pointers at one location. Okay. So Is there any possibility of meeting so slow and fast pointers at any location, at one location, if so the last node next is connected to the null? No, right? Always fast pointer is ahead, okay? So if again, so if slow and fast pointers are meeting at one location means definitely, so there is a cycle, okay? We can so identify so in this way, okay? So let me complete so that one. So with the help of so the example, you can understand detail. Okay. So this is the head address. Okay. Initially, we are taking slow and fast pointers to the head address here. Slow and updating so to the node 2. Okay. So fast. So we'll go for updating to the node number 3. Okay. And so slow and updating to the node 3. Fast we update to the next and next of next. Okay. So slow and updating to the next, okay. Fast we updated to the next of next, it reached to here, okay. Next is slow and updating, so to here, so fast currently is pointing to here, right. Fast updates to the next of next, right, okay. So now you can observe here, so both the slow and fast pointers are meeting at one location. So here, so if both these two are pointing at one location means definitely we can say that so cycle is existing, okay. So in the linked list, okay, there is no possibility of so fast pointer so meeting to the slow pointer if last node next is connected to the none, okay. So if they are meeting at the same point means definitely fast pointer after reaching to the last node again, so it is moving to the some other node in the linked list, okay. So in that scenario only, so slow and fast pointer so that meets at one location. So simple, easily, so you can do it. The condition is for suppose if fast next, for suppose you observed the node 1, okay, simply one node is given, okay. So to that one node, what happened? So the next is none is connected, okay. If fast so is none, so until fast is not is equals to none, so RS and fast dot next fast dot next not is equals to none, we should keep on repeat the loop, okay. So here might be so the empty linked list might be so given, okay. And so if it is not in this scenario, you can observe only one node is given, fast next not is equals to none means here it's pointing to none, we need to stop it, okay. So in both those two scenarios we need to repeat so the loop here. So let us see the constraints here, okay. Number of nodes in the list are in the range of so the 0 to 10 power 4, guys, okay. So 0 nodes existing means so the empty linked list also so passed as input here, okay. So empty linked list means we need to return so the false, okay. And if I suppose slow and fast pointers initially, so we taken to the node 1 here, okay. So here fast dot next is so not is equals to null means it's pointing to null, right. So it is not going to be updated. So based on that, it is going to end the loop. For suppose if loop is ending means so outside of that loop, we are going to return the false. Listen, if let us take so this one only, okay. So here finally after reaching so the fast to here, okay. For suppose if this connection is not there, okay. Fast next if it is not pointing to null means so loop is going to be ended, right, okay. This is the condition, these are the conditions we are going to take in the loop, okay. If fast not next not is equals to none, then only it so again updates fast pointer. If it is pointing to none means it stops. If it is pointing to the none, then only loop stops. When control comes outside of the loop, whenever any one of these conditions so becomes so true, right, okay. Whenever any these conditions so becomes false means if fast reaching to the none or is fast or next reaching to the none, it is going to stop, okay. So in that scenario, so we need to return so the false, guys, okay. That is a problem statement here. So here let us check with the help of an example program, okay. Have a look everyone. So here hash cycle method is given, head address passed here, and we need to return so the boolean value. Okay, and so slow initially I'm taking so to the head address, and fast pointer initially I'm taking to the head. Okay, so if for suppose fast on reaching to the null also we need to stop it, or else fast dot next not is equals to none on reaching to this one also we need to stop it, because you observed constraints here, chance were there to have zero node, okay, and chance to have so the one node, okay, and that too in that scenario might be if it is not connected to the self node, okay. If only one node is there, and in that if only one node is there, and that too if that node is not connected to the same one, okay, in that scenario, so if it is pointing to none, then only it stops here, okay. So if not pointing to this none, so what we need to do? Slow simply we should update to the next location, and fast we should update to the so next of next location. Okay. After updating, so each and every time we should check whether so the slow address and fast address both are same or not. Okay. So we are not comparing so values here. Okay. So addresses, guys. Okay. If both are so pointing to the so same address means there itself we can stop and so return true. Okay. But suppose if loop ended and control came outside of the loop, means if this condition became so the false, or means fast reaches to the none, or as fast dot next reaches to the none, what is meaning of that? So there is no cycle, right? So it's pointing to the null. Then in that scenario, control comes outside, we need to return so the false. Okay. I hope so you understood. So this one, let us check. Let us run and execute. This guy is executed, guys. Okay, let us submit now. Yeah, fine. All test cases so passed here. Okay. So that's it with the help of so the two-pointer approach, so Rabbit and Hooray approach. So we can how we can finish this observe everyone. That's why I said so this two-pointer approach is very important here. This plays very key role. Okay. So let us meet in the next video. So guys, thank you everyone.